Hello and welcome to my FreeRTOS demonstration. My name is Wai Luong and today I'll be showcasing what I have so far on the FreeRTOS project for embedded architecture at Cal State LA. So in order to demonstrate my project, I will have to show the following components for this project required. The DC motor, LCD module, the PSOC 5LP, RTC module for the real-time clock, ultrasonic sensors to calculate the distance between the object and the sensors itself, a push button to display between the current date and time and the distance and temperature calculated values, and the LCD L923D chip to power up the motor, along with the transistors and diode in order to increase the gain for the motor. And lastly, the power module to power up the components that require 5 volts. And now I will be moving on to my top design for this project. So in PSOC, a top design is necessary in order to implement these components overall. In order for the hardware components to actually read the code based on the top design that the component requires. So in this case, this project, the software design part of this create PSOC code requires an LCD, a UART, which is essentially an interface from Termite right here in this case, that will take in 2 power commands, power on and power off, and obviously the fan to adjust the fan speed, and the ADC module to help the temperature sensor calculate the values of Celsius, a timer for the ultrasonic sensor to trigger a sound wave and receive back the distance to the echo pin when the sound wave bounces back from the object, so it can determine the distance between the sensors and the object. A PWM component to adjust the duty ratio on the motor speed, and then we will use an I2C component to obviously display the current date and time on the LCD module. So now in order to demonstrate, I will have to plug in this PSOC chip or controller inside the laptop like this, and then turn on or push the button on the power module. Now what you'll see here is a display. I don't know if you can see it clearly, but this is the display of the temperature in Celsius and the distance calculated from the ultrasonic sensor. And once the sensor picks up a distance less than 10 centimeters or a temperature that raises up to 40 Celsius or greater, the motor will have to turn on. And if those values do not go beyond your threshold, then the motor should turn off. And in this case, the motor is still turning on because the distance is still still greater than 10 centimeters for sure, but the numbers are still staying there. And for the RTC, in order to display the current date and time, in this project, we implemented the the RTC code from the previous from the past lecture, in order to fully implement how we would display the real time into the LCD. And in order to display it, one of the requirements is to show only the time and date by pushing the button here. If you can see my finger here and the push button here, and once I press it, it displays the date and time, which is what we needed. And then once I let it go, it will show only the time and distance. And for the UART, the way this works is the user has to type in the following commands: power on, hashtag and hashtag power off, and hashtag fan, along with the number corresponding to the duty ratio, in order to control the entire system based on the user's input. And that is pretty much it for this project. The requirements for this project are fulfilled, partly, but not most of it. But for this project, it's doing most of what it needs to be fulfilled in this case. And I think that is it for the most part. Thank you for watching. I hope you have a good day. Stay safe and have a good day.